Hello everyone, welcome back. Today topic will be the light reactions, which are also called as a light dependent reactions, also called as a photophosphorylation reactions, where ATP is preparing by utilizing the light energy, and also called as a photochemical process, where light energy converting into chemical energy. As we see that photo means it is coming as a light, and chemical means it is equal to the ATP and also NADPH2 formation. Here we see that photo means light. So that is why that these reactions are called it as an photochemical reactions also. And the first reaction what we see is as a non-cyclic photophosphorylation. Basically, light reactions are of two types. One is considered as a non-cyclic photophosphorylation, where electrons get excited and cannot come back to its original position into the ground state. In the light reactions, we see that electrons get excited, again come back to their original ground state. So due to that, we see that non-cyclic photophosphorylation where they do not come. So that's why we call them as a non-cyclic photophosphorylation, where electrons get excited, prepare the ATP and go back to the NADPH2 and never come back. So it is all started in the leaf inside mesophyll tissue inside. Generally we see that in the chloroplast inside it is a thylakoid contains two membranes, that is outer membrane and also inner membrane, and the space present between the in the open space is called as a lumen. In the lumen only, this entire part only, if we see in the zoom in, there we see that PS2 and also PS1. So this arrangement will be why do we call them as based on their discovery. First they discovered the PS1, later they discovered the PS2, but according to their function, PS2 first comes and later it becomes the PS1. Why PS2 come as a first? Because once the energy coming from the sunlight in the form of the photons, that energy will be first taken from the lowermost nanometer of wavelength, that it is having that energy is having high energy is traveling towards the lower energy level where they do not have the energy. 440, then it's sent to the 460, then 470, then 500, then 550, 610, 630, 640, then 680. Then finally the primary acceptor of these electrons is nothing but in this area we call as a reaction center, where we call this as a PS2, photosystem 2. Why do we call photosystem 2? Because it is a containing light harvesting complexes like carotenoids, xanthophyll, chlorophyll B, and we also call the antenna, because they are accepting the photons and traveling that electrons energy to the other systems also. So this is also called as a very important and sending to the reaction center, where compulsory always it is a chlorophyll A only, and because it contains some of the enzymes also which are necessary for the photochemical reactions. So that is why we see here that always it is sending from the lower nanometer wavelength to the higher wavelength, but we can say that lower nanometer wavelength like 440, 400, it is having a high energy sending to the lower energy which do contain that. So what are the highlights of this is nothing but non-cyclic splitting of water, ATP and NADPH2 formation, PS2, PS1 are involved, granule lamellae takes place, no cycling of the electrons. Only once it is passing, there is no repetition. So it is not starting from here. First PS2, once the photons electrons energy is coming to this wavelength of this also 400, then 440, 450, 470, 550, then again it is sending back to the another 552, again it is sending to the 600, then 640, then 600, like this. Finally it reaches to the 680. Then from here the outer state, the two electrons are get excited. Once they get excited, it is been accepted by the primary electron acceptor. Primary electron acceptor pass that electrons to the PQ. PQ stands for plastoquinone, where it is accepting and giving back to the cytochrome B6F. Interesting point is here electrons are not used. They are only helping for transporting of electrons to the next lower state also. Like as we see that 682 can be sent to the 700. Again they are not sending back to the 600. So cytochrome B6F, it is converting this ATP plus inorganic phosphate, combining making the ATP. So this process also we can call it as a ETS. ETS, why do we call it? Because electrons transport system. Electrons are getting transported. So we can also call as a chemiosmosis. Chemi means chemicals moving from a higher energy level to the lower energy level. So we call them as a chemiosmotic process also. We call it as an ETS also. Later on, from cytochrome B6F, the electrons are passing to the plastocyanin. Plastocyanin again passing that electrons to the chlorophyll A. Here chlorophyll A also at the same time it loses the electrons, no? So it is sending to the primary electron acceptor here FeS, iron sulfur, then ferridoxin. Then in the presence of an enzyme NADPH plus 2H plus 2 electrons giving rise to the NADPH2. So NADPH2 formation taken and ATP formation is taken. Once both at the same time electrons they loses. These electrons are coming and giving here, and these electrons giving to the NADP plus. But here who is there to give for here? The splitting of water takes place. Photolysis also we can call it. Photo means light. Lysis means breakdown. They are using the light energy to split up the water. So H2O splitting to form the 2 protons, 2 electrons plus half O2 is giving rise to. So to form a 1 O2 molecule we require the 4 protons especially. That means 2 H2O molecules we require. So these electrons which they are forming, they are again coming back to the lower energy, again going back to the more energy areas. So this is how the main non-cyclic photophosphorylation taking place. Water is giving that electrons get excited, electrons PS2 to PS1 they are reaching, from PS1 to NADPH2 they are reaching. So the main highlight is preparation of the energy. I recall once again the main process are splitting of water, ATP and NADPH2 formation, PS2 PS1 is involved, grana lamella it is taking place. This is entirely we call it as a entirely grana lamella only, and each thylakoid non-cyclic of the electrons. Once the electrons are moving, again they never come back to this original state. Thank you for watching. Please subscribe my channel. Thank you.